To pursue honors, lesson 5.3, transforming parabolas. Okay, let's recall, remember in chapter 2 when we would graph absolute value functions, for example, y is equal to 2 absolute value x plus 3, let's say minus 5. Okay, so remember we would find the vertex, right? So we would do opposite sign here, right? Opposite sign divided by the number in front of x. So the vertex would be negative 3 and negative 5. So this would be our vertex. It would go over as negative 3, negative 5 would be right here. And then since we could use the shortcut here, we could use the shortcut method. We just look at the a value. If it's positive 2, that means you would just move over 1 and up 2 since it's positive 2. And then you can move over 1 and go up 2 again. And you can actually just keep on repeating the process to get more points if you want. And you would do the same thing on the left side. Over 1, up 2. Over 1, up 2. And then we would get our v, right? And then, so we've just graphed our absolute value function, right? Now you notice here, we could keep on repeating this process of going over 1 and up 2, right? Because a v, the absolute value function, is linear on the right side and on the left side. Okay, that's an important concept to keep in mind. An absolute value function is linear, right? You notice it's a straight line here. Now, as we move on to today's lesson, we're going to talk about graphing a quadratic, right? That's in vertex form. Now, this is considered vertex form of a quadratic right here. In 5.2, we learned about standard form, right? But this is vertex form right here. Basically, the h and the k, right? The h and the k right here represents the vertex. And everything is almost exactly the same in terms of graphing a quadratic and a v, except for some small minor differences, and I'll point that out in a moment. But just keep in mind, this is the vertex form of a quadratic. Okay, the a value is in front of the parentheses instead of the absolute value now. So the a value is in front of the parentheses instead of the absolute value. And the a value, right, we're going to use it kind of the same way to graph, using the shortcut method. Alright, so let's do an example real quick. So let's say we need to graph this right here. Okay, so this is going to be the same thing as graphing using the shortcut method. Right, very similar. So we're going to find the vertex, right, same way. So opposite sign here, right, opposite sign here, then divided by the number in front of x. So we're going to end up with positive 2. Right, the y value will be 3. So positive 2, 3. So here's our vertex. Okay, now we're going to use the a value again to get the other points. So the a value is negative half. So remember what that means is when you go over 1, you go down a half. Now here's the difference. When you go left once, you go down a half. Since a quadratic is not linear, all right, a quadratic is u-shaped, right? It's not linear. When you go over 1 and up or down, whatever the a value is, you can only do that one time, right? If you actually go over 1, all right, and down a half again, you're not going to be on the parabola. Okay, so that's going to be inaccurate. So you can only really do this, repeat this, right, one time. Okay, so using the a value gets you these first few points here, but that's really all you need to graph a parabola. Okay, so just keep in mind, all right, you can't just keep on repeating the process of going over and up or down whatever the a value is, because a parabola is not linear. Okay, so we can sketch our parabola right here, right? All right, remember trying to make it kind of U-shape. Okay, so you notice if you go over 1 and down a half again, you're not going to be on the parabola. Okay, because the parabola is exponential. It's not, all right, it's not linear. Okay. But you notice in terms of graphing, it's pretty much almost the same thing as graphing an absolute value function. Let's try another one real quick. Let's say we need to graph y is equal to 3 parentheses x plus 4 squared minus 1. So the vertex here is going to be an opposite sign divided by 1. So negative 4, negative 1. So negative 4, negative 1, here's our vertex, right? we're going to use the a value next, positive 3, so that means when you go over 1, we're going to go up 3, 1, 2, 3. Alright, go to the left ones, go up 3. And remember, you can only do this one time, alright, when the shape is a going to be a parabola, alright, if the problem is a quadratic. So then, here's our graph. And that's it. Alright, so basically, if you know how to graph an absolute value function, you pretty much know how to graph a quadratic also. Okay? Now let's talk about, what if I give you a graph, you should be able to give me the equation, right, in vertex form. So we're going to find the equation of this in vertex form. So the vertex we have right here is 3, positive 4. So if the vertex is 3, positive 4, remember we have y is equal to. So if x is 3, we're going to put minus 3, remember opposite sign. Don't forget the square, that's very important. That's what makes the problem a quadratic. And then positive 4 goes outside here, right? And then the a value, well, if you go over 1, when are you on the parabola again? Well, it looks like you go down 2, right? Go over 1, down 2. So that means that the a value is negative 2. You notice here, if you go over 1, down 2 again, are we on the parabola? No, because the parabola is not linear. Okay? So here's our equation in vertex form. Okay? Real simple. Then let's talk about the a value. Remember when we talked about in chapter 2 an absolute value function, when it gets wide and when it gets narrow? Those same rules apply for a quadratic, for a parabola. Okay? So first of all, if a is positive, alright, the shape is going to be a U, right? Or what I kind of call like a happy face, right? Or a U. If a is negative, right, we know that the parabola is going to be upside down, right? Or sad, as I like to call it. Remember, we call this opening up. We call this opening down, right? So if a is positive, you know that it'll be a U. If a is negative, you know that it's going to be an upside down U, right? Now the next thing, the same rules apply, like I said, in terms of narrow or wide. So if the absolute value of a, right, if the absolute value of a, right, the more it increases, greater than 1, right, the narrower the parabola will get. And if the absolute value of a, right, is less than 1, right, so if it's less than 1, or like a fraction less than 1, the parabola will get more wide. Right, it'll get more wide. Okay, so meaning, let's say using some of this right here. So this green parabola right here, the a value, right? The a value we could assume could be something like 1/4. All right, this one in red, right? The a value, right? So, something that would make sense. A might be something like 2, 3, something like that. Okay. And then this one right here in blue, right? It'll be, I would guess it'll be it would be something like let's say a half. Okay. It can't be smaller than 1/4, right? Because this one was wider, so a half, right? And you guys get the point. So same rules apply that you guys learned in chapter 2 regarding absolute value functions, alright, and the a value. And then let's talk about converting to vertex form. Okay. So this is in standard form right now, right? So we learned about standard form of a quadratic in 5-2. So now we want to convert this to vertex form. So to convert to vertex form, you have to find the vertex. Alright, so remember, to find the vertex, we had that little formula that I taught you guys. Negative b over 2a. To find x. Oops. Sorry, plug in x. And to find y, you plug in x. Alright, so first thing we're going to find the x value of the vertex. So it's negative, and then whatever the b value is, in this case 10, divided by 2 times whatever a is, in this case 2. So we end up with negative 10 over 4, which reduces to negative 5 over 2. So the x value of the vertex is negative 5 over 2. Okay. To find the y value of the vertex, we have to take x and plug it back into the problem. Okay, into the problem. So y is going to equal 2 times negative 5 over 2 squared plus 10 times negative 5 over 2 plus 7. Okay, so let's work this out. Now, a few common mistakes that I see that I want to make sure you guys don't do. First of all, you have to make sure you follow the order of operations, meaning you can't cross cancel or divide out the 2's right now because that would be inaccurate. Alright, you have to follow the order of operations, meaning you have to square the exponent first. So you have to square this first, right? Simplify the exponent first, so we're end up with 25 over 4 times 2, right? And then over here, the 2 and the 10, those divide out. We end up with negative 25 plus 7. And then so this right here reduces. So we end up with 25 over 2, right? Let me write that right here. 25 over 2. And then let's get common denominator, right? So if the common denominator is 2, so this would be 50, right? And then if the common denominator is 2, right here, this would be 14. Okay, all I'm doing is I'm getting common denominators so that we can simplify all this. So we simplify all this now. This will give me negative 25 over 2. Negative 25 over 2 plus 14. That'll leave me with negative 11 over 2. So the y value of the vertex is negative 11 over 2. Okay, so we've just found the vertex, right? Now that we've found the vertex, we are going to put it in vertex form. So the equation is going to be y is equal to, and then we have the vertex here. So since this is negative, it's going to be x plus 5 over 2. Alright, don't forget the squared. Then we have minus 11 over 2. So there's our vertex, right? And then the a value, well, the a value is right here, right? They gave us the a value. We know the a value is 2. So here's the equation in vertex form. Okay? So this is the problem in standard form, and we've just changed it to vertex form. Okay? The next thing I want to talk about is let's talk about translating. Okay? Now in translating parabolas, translating and changes in the a value. Okay, so let's say we have a parabola y is equal to 2 parentheses x plus 1 squared minus 6, and then it's translated to y is equal to negative 1/2 parentheses x minus 3 squared plus say 4. Okay, so first of all, the vertex, you guys know how to find the translation of the vertex. That's the same way that you learned for absolute value functions in chapter 2. Okay, so the vertex of this right here is real simple. Since this is in vertex form, vertex is going to be negative 1, negative 6. The vertex here is going to be positive 3, 4. So to find the translation, right, so for the x values, if you were at negative 1, right, just think of like a number line. Alright, here's the x-axis. If you were at negative 1 and then you ended up at 3, right, what did you do? Alright, you were at negative 1 and you ended up at 3. Well, we moved to the right 4 times, right? And then for the y-axis moves up and down, right? So let's say the y-axis right here. If you were at negative 6 and then you ended up at positive 4, right? Which way did you move? Well, it looks like we move up, right? We move up how many spots? Right, we move up 10 spots. So this is still the same as you guys learned in chapter 2, right? When you first learned this regarding absolute value functions. Now, what I've introduced in this chapter, in this section, is now there are going to be changes in the a value here. So you notice here there are changes in the a value. A changed from 2 to negative 1/2, right? Now a doesn't have to change. I'm just telling you it might. If it does change, right, you have to be able to describe what happens in the a value, right? So if the a value changes, what happens in the graph? So if it changes from 2 to negative half, right? Let's just think of the numbers right now. 2 to negative half. So what happened? The graph got wider, right? It got wider. And then if it was positive 2, right? If the graph was positive up here, that means if I graph this right here, let me erase this over here real quick. If I graph this right here, I know that it'll be some sort of U-shaped figure like this, right? If I graph this one right here, it's going to be negative 1/2 if that's the a value. First of all, it'll be a little bit wider, and then it'll also be upside down, right? So what happens is, if you take a look at, if you think of like a graph, let me show you guys a graph real quick. Let's go back to our graph. So for the first one, we have a U like this. The second one, we have a wider U like this, right? So what happens is, if it was like this, and then it ends up like this, the parabola flipped across the x-axis right here, right? It flipped across the x-axis, or as you learned in geometry, that was called a reflection, right? So what you're gonna call it, what you're gonna say is, the parabola, it reflected, right? It reflected across the, right, x-axis. Alright, so it was like this, right? Because the a value, remember, a was equal to 2, and then if a is equal to negative half, the graph got wider, right? And if it's negative, that means it flips across the x-axis, or it reflects, and that's why it's upside down now. So when the a value changes from positive to negative, that means there's a reflection across the x-axis in this case. Okay. So let's do an example real quick. Let's say we have y is equal to 2 parentheses x minus 4 squared minus 6, and then 2y is equal to, let's say, 5 parentheses x minus 1 squared plus 2. So first of all, let's find the vertex here. Vertex is 4, negative 6. Over here, the vertex is going to be 1, positive 2. Right, 1 and positive 2. So if we were at 4 on the x-axis and we move to 1, let's say we move to the left 3 spots. Then over here on the y-axis, if you had negative 6 and you moved to a positive 2, let's say we moved up 8. So that's the translation there. And then let's take a look at the a value. Well, a was 2, then it changed to 5. Right? So remember, if this number is increasing, right, that means the graph is getting a lot more narrow. Right? So it got narrower. Alright, and then if it's positive both times, that means if you graph it, it'll look like this. And over here, this one gets more narrow, it'll look like this. Right? So it doesn't reflect across the x-axis. Okay, remember, there's only a reflection when it changes from negative to positive. Okay.